So in this video, we're going to look at solubility calculations. And before we jump into our examples, there are a couple of things that we need to make note of first. And the first is two terms, which are molar solubility and at a temperature. So when we're looking at molar solubility, that's just another way of saying molarity, which means we're going to be looking at moles over liters. Now, when we say that these things are soluble at a certain temperature, that's because temperature can increase or decrease the solubility of a compound. So temperature can increase or decrease the solubility. Now, that just means that if you increase the temperature, it can become more soluble. If you decrease the temperature, it can become less soluble. All of our calculations are going to be done at 20 degrees Celsius, so the temperature doesn't really matter. It's not going to play into our calculations. It's just important to note that temperature can alter the solubility of something. So now we're going to come back and we're going to look through 4 different examples. We're going to start with this one up here at the top. So this says that the solubility of sodium chloride in water is 360 grams per 1 liter. We're actually going to use sodium chloride in water as our example for all of our calculations that we're going to do in this video. So the first question that we're going to look at is just calculating the molar solubility. So again, like I said, molar solubility, we're really just looking at molarity, which is moles divided by liters. Now, if I look at my solubility that I'm given up here, I already have liters, so that's good, but I need to convert my grams into moles so I can get my moles units that I need for my molarity calculation. So in order to convert grams into moles, I need my molar mass. Okay, so that's my first calculation I'm going to do. I'm going to find my molar mass of sodium chloride. So we've done this before. We're going to use our periodic table. Sodium is 22.990. Chlorine is 35.45. You add those up, and you get 58.44 grams per mole. Now, if I'm going from grams to moles, I'm going to divide by my molar mass. So I'm going to take my 360 grams, I'm going to divide it by my 58.44, which is my molar mass of sodium chloride. So I do 360 divided by 360 divided by 58.44, and you get 6.16 moles. So when I'm asking about my molar solubility is moles per liter. I converted my grams into moles, so it's 6.16 moles per 1 liter. We could also say it's 6.16 molar. So that's one way that it's similar to concentration, but molar solubility is the same thing as moles divided by liters. So that one was pretty easy. So now we're going to come over here and we're going to do example number 2. So again, still working with sodium chloride. So it's 360 grams in 1 liter. In this case, in this question, I want to know how many grams are going to dissolve in 300 milliliters. So before I actually answer the question, I need to look at my volume units. So my solubility is given in grams per liter. My question is asking about milliliters, so I need to make sure that those are the same. So I'm just going to rewrite this as 360 grams per 1,000 milliliters. And that's just because 1 liter equals 1,000 milliliters. So I'm just writing it differently. I don't have to actually divide those numbers. I'm just writing it so that my units match. Now we're going to use these as a ratio. So we have X number of grams in 300 milliliters is equal to 360 grams in 1,000 milliliters. So our solubility is the maximum, or it's what we're looking at. That's how much possible we can dissolve in a certain volume. So I know that I can dissolve up to 360 grams in 1,000 milliliters. So I want to know how many grams I can dissolve in 300 milliliters. So we can then cross multiply. So this is pretty straightforward. So we have X grams times 1,000 milliliters equals 300 milliliters times 360 grams. X grams times 1,000 milliliters. Oops. So now I'm just solving for X. So I'm going to do 300 times 360. And I get 108,000 milliliters times grams. So then I'm going to divide by 1,000 milliliters on both sides. And I need a little bit more space, so there we go. So 1, 2, 3. I get 108 grams that I can dissolve in 300 milliliters. So that's it. Pretty straightforward. Okay, so now we're going to look at a different question. Similar, but a little bit different. This is actually kind of the opposite style of question. So still looking at solubility of sodium chloride, 360 grams in 1 liter. But in this case, I want to know how many milliliters is it going to take to dissolve 13.6 grams of sodium chloride. Okay, so again, I need to make sure that my volume units match. So I'm going to rewrite this as 360 grams in 1,000 milliliters. Again, I can do that because 1 liter is the same as 1,000 milliliters. And in this case, I know my grams, so I have 13.6 grams per X milliliters. And then I have 360 grams per 1,000 milliliters. I'm going to cross multiply. So this is the same style of solving that we did before. So we have X milliliters times 360 grams equals 13.6 grams times 1,000 milliliters. So now we're just solving for X. Probably didn't need to type that in my calculator, but just want to make sure I get the right numbers. And then solve for X by dividing both sides by 360 grams. So I do 13600 divided by, oops, dropped my 0 there, 360 gets me 37.78 milliliters. So if I'm going to dissolve 13.6 grams, I need 37.78 milliliters in order to do that. So similar style as the previous question, just solving for something different. Okay, we have one more problem that we're going to look at. Where's my problem? There it is. Okay, in this question, still using sodium chloride, still has a solubility of 360 grams in 1 liter. In this case, we want to decide if something is saturated or unsaturated. So saturated meaning that we can have the max amount of solute, and unsaturated meaning we have less than the max. Okay, so if something is saturated, it's going to have the solubility of 360 grams per 1 liter. So what we're going to do is we're going to find our ratio that I gave you in the problem, so 100 grams and 600 milliliters, and we're going to compare that to our solubility ratio of 360 grams per 1 liter. So I'm going to do my 100 grams in 600 milliliters. So when I do 100 divided by 600, I get 0.167 grams per milliliter. And then I'm going to do my 360 grams in 1,000 milliliters. Again, I'm rewriting this just because 1 liter equals 1,000 milliliters. Oops, keep dropping my zeros. So if I do 360 divided by 1,000, I get 0.360 grams per milliliter. So I'm going to compare these two numbers. Since the amount given in the problem is less than the max, so it's less than the solubility, it means it is unsaturated. If it was the same as the solubility, that means it would be saturated. So since this is unsaturated, it's less than our solubility. And we could also use this to figure out how many more grams we could dissolve if that was something that the question asked. This question just asked, is it saturated or unsaturated? But from here, we could determine how many more grams we would need to dissolve in order to reach a saturated solution. So those are just several different ways that we can use solubility to do a variety of different calculations.